Hello everyone. So today again we'll discuss one question from CAT 2020 slot 1. So the question is moreover related to uh, coordinate geometry. Let's directly move to the question. Right. So it's moreover related to coordinate geometry. So I have a coordinate graph available here. It's given the area of the region satisfying the inequality modulus of x minus y is lesser than or equal to 1. Y is greater than or equal to 0 and y is less than or equal to 1 is. Right. So according to this, first let's try to identify what is a graph for modulus of x is equal to y. Right. We'll try to understand the shift of the graph for the time being. Right. So if we'll consider this, normally the graph will be in this format, or else we can say, if we'll take some example, suppose I have taken x as 1, the value of y will be 1, x as minus 1, the value of y is 1, x is 2, the value of y is nothing but 2, x is minus 2, the value of y will be equal to 2, and so on. So my graph will be in this format, right? But here my condition is the value given is modulus of x minus y is lesser than or equal to 1, right? Assuming if we'll take a condition as modulus of x minus y is equal to 1. So let's talk about the graph for this part here for the time being. Here I can say that the value is nothing but modulus of x minus 1 is equal to y, right? So let's take some values for x and y here. X and y let's consider, right? So assuming if we'll take x as 0, the value of y is supposed to be minus 1. If I'll take x as 1, the value of y is supposed to be 0. If I'll take x as minus 1 also, the value of y is supposed to be 0. Then if we'll take x as 2, the value of y will be equal to 1, and x as minus 2, it's again 1, right? That means I'm shifting the graph. In this case I'm shifting the graph towards downside, right? Or else I can say my graph will be like this, right? But now my condition is it's this value should be lesser than or equal to 1. So here we apply a basic zero test. Zero test says if I have the value as let's say left hand side and right hand side, I'll insert x and y as 0 and 0. If left hand side and right hand side values are there, if the equation is true, I should move towards 0 coordinate. If the equation is false, I should move away from 0 coordinate. That's the basic condition here. So here I can say 0 minus 0, which equals 0, is lesser than or equal to 1. This is true, that means I have to move towards 0 coordinate. So where is my 0 coordinate? This is my 0 coordinate here. That means the area which satisfies the condition will be towards 0 coordinate here, right? Towards 0 coordinate. So this will be the area which will satisfy my condition, right? So I'll just mark it. These will be the areas which will satisfy my condition here. Now since these are the areas which will satisfy my condition, I'll go for the other conditions here. So it's like a funnel here. Other condition is the value of y should be greater than or equal to 0 and y should be lesser than or equal to 1. Y should be lesser than or equal to 1, right? So if y is less than or equal to 1, let's talk about this thing. and the other one, if we'll take these two graphs, it would be like, also let's take the value of y is equal to 1. If we'll take y is equal to 1, I have another graph available here, right? So this is nothing but y is equal to 1, and I'll take y as equal to 0. So this line represents y is equal to 0. Now again I'll apply a 0 test here. Here, according to this, y is less than or equal to 1. If I'll put y as 0, less than or equal to 1, that means I have to move towards 0 coordinate, right? So the value which will satisfy my condition is from this line I have to move towards 0 coordinate, right? Now if we'll see, according to this, and its y should be greater than or equal to 0, right? So that means I should move away from 0 coordinate here. So what is the area which is available here? Area, bounded area, is nothing but this part, right? If we'll check, this is my bounded area. I'll just mark this one with some color here, so you can identify this is my bounded area available here. If this is my bounded area available, it's something but a trapezium. It's a trapezium of this kind, right? With this length will be nothing but 4, as this part is nothing but, now you can identify in the graph, this is 2 units available, this is 2 units available, or else we have seen the conditions here for this one, when x is equal to 2, the value of y was nothing but 1, right? And vice versa are the values available. So let's check. So this is my area available. With this part is 4, this part is 2, and this length is nothing but 1, which we have considered. So area of a trapezium, if we'll go by the formula of area of a trapezium here, it's nothing but area of a trapezium. This is A, this is B, and this is height h of trapezium. Let's consider it's nothing but half of A plus B into height h, right? So here the value is supposed to be half of 4 plus 2 into height is but 1. That reflects the area is half of 6, which is 3. So my area is supposed to be 3, right? So that will be the relation here. Okay, so that's all for today. Thanks for joining us.